Hello everyone, this is Mr. Ege. We're going to focus on completing the engine block of the V8 engine today. And you're going to find the most of the dimensions available in the Schoology document. I left it over there for the specifications for the V8 engine. It's going to be an inch system. You're going to start a part drawing in an inch system. I already did that ahead of you right now. And I selected an YZ plane and I created a sketch number one, basically. And as you can see now, YZ plane is in front of me and I have the crosshairs, okay, crosshair lines, axes, Y and Z axes intersecting each other, 0, 0 point. Now remember 0, 0 point is my startup point, okay? And in generally, it's a wise thing to do to start from there. So I'm going to go with the line command, okay? And start a brand new line. This is going to be the center of the engine, hopefully, bottom at least. And we're going to move to the left about 3.1 inches. And I'm going to the left. So 3.1, I'm typing 3.1, enter. Okay, and now we need to go up. Okay, and the length of the line is already highlighted. Okay, and 1.57. So that's going to be 1.57. Enter. All right, so now at this point, I am going to go 120 degrees angle and I'm sorry, it's 90 degree plus 45, 135 degrees. Okay, it's supposed to be because 90 degrees. We're going to add the V8 engine blocks. Okay, and each cylinder is supposed to be making 90-degree angle with each other. For that reason, we have 90 plus 45 degree, 135 degree angle. Okay, I'm going to press the tab key so that it highlights the angle for me. And now angle is 135. I'm typing 135. And I hit the tab key and the length is going to be 1.95. I'm typing 1.95. Enter. Okay, and move my cursor 90-degree angle to the past last line. Okay, it says 2.92. 2.92. Enter. Okay, and again 90-degree angle and any tiny small. Okay, this is very, very small. Perhaps it's 0.225. Okay, inches distance, and now we're gonna go 3.3 inches. Okay, 3.3, enter. And again, 135 degree, 0.23, click. And now we're going to draw a vertical line. Okay, about the same as the 2.92 as we did before. And if I extend my cursor enough, computer shows me when it lines up with the existing previous point. Click. Okay, and I'm going to 90-degree angle. Again, I'm showing my line cursor extending enough so that the computer shows me. Again, the footprint of the mirror line on the other end. Okay, and when I see the footprint, when it's lining up perfectly, click, and you're going down from here, again lining up, and then you're going at here. Cool. Okay, this is the engine block. Okay, and engine block lines, construction lines. All right, not engine block yet. It didn't become engine block yet. We need a circle at the center. Okay. All right, so we got the circle command. And we need to also draw a center line, perhaps it really helps. So if you start from here, from one end, okay, 1.5, 1.65. 1.65, okay, perfect center. And I need to establish the center of this engine block. And I'm drawing a center line now, okay? All right, the crankshaft, okay, will be located here. So the dimension for the crankshaft is giving somewhere else. I'm going to simply go back and check this right dimension. That hole that I'm going to integrate is going to be slightly larger than the command crankshaft. Okay, this the diameter is 0.22. All right, so we're going to draw the circle here, and with the diameter. All right, it's going to be 0.47. 47. Okay. Now we need to do some trimming. Okay, and enter. I think everything is ready to be extruded. I am going to erase the center line. We don't need this anymore. Not at this point. Okay. All right. So we're finishing the sketch. Okay. Going to extrude command and changing our angle a little bit. And we're going to just do it in two directions. And the total length is going to be 11 inches. Okay. All right, so the engine block is going to be located within this system, okay? And at this point, we're going to select, all right, there's going to be 4 cylinders on one end, the 4 cylinders on the other end, okay? So we need to select a plane to work for, okay? And I'm selecting this particular plane and I'm creating a sketch on this, all right? It's always a good idea to draw a center line. Click. Okay, because the cylinders are going to take place, and also it's always a good idea to draw a center line again in the middle of this. Okay, and the cylinders are to locate the cylinders. We're supposed to have circles. Okay, and anytime you draw a circle, you have to know for a fact how far they're going to be from each other. The center of the circles has to be located. All right, the circle diameter is going to be 1.88, but center to center distance is 2.40. Okay, so the half of that 2.40 is 1.2. So we're going to offset, okay, this line 1.2. Enter. Now that that is done, we can offset another line from here. Okay, that's 2.40, 2.4, enter, and another offset to the left side, 2.4, enter, and another offset to the left side, 2.4, enter. Okay, and those lines actually establish the center points of each cylinder. Okay, now I can go to circle command and select the end of the lines without intersection with the center point. Okay, and create a circle from that point, and computer is expecting me to enter the diameter, and diameter is 1.88. I'm typing 1.88, enter. Okay, and do the same thing for the next circle. 1.88, next circle. 1.88, and next circle. 1.88. Okay, so we established the location of each piston housing. Okay, and we're going to, next thing to do is we're going to extrude these. Okay. So in order to decide the extrusion, okay, depth, we have to do a little bit math, okay? And we know that the half of the width is 3.1 of the build of the block, okay, 3.1, and that is a 45-degree extrusion, so that's why we need to divide 3.1 by sine 45. Okay, that little map really goes a long way. So please take out your calculators, okay? And type 3.1, all right, divided by 45, sine, enter, and 4.38. So that's what I'm going to do. I'm just going to simply change the angle, okay? And finish the sketch, extrude each one of them, okay? In opposite direction. We did cut. Okay, and we're going to decide it's going to be 4.38. Let's say 4.4. All right. We should do the same on the other side as well. Because the system is symmetrical, I'm just going to be copying this configuration. We don't need those lines anymore at this point. But what we need is a copy of the images. And we're going to see if we can copy that. Okay. Or Control C, see if we can apply it on the next sketch. So finish the sketch and turn the system around. Okay, select the plane, create a sketch and Control V. See if you can move these. Okay, where they're supposed to be. Maybe we should draw a line at the center. Use move command. Okay. All right, so before we do the extrusion, again, we're going to erase the lines that we don't care right now. Okay. And finish the sketch, use the extrusion, select the entities for the path in opposite direction, okay, and .4. All right, this is done. Pretty good. All right, save. Every time you finish achieve a 3D model option and solid model part, just go to save in a proper folder. I mean, it's always good idea to create a folder. Okay, so this is V8. And make sure you put your name. It's your intellectual property. It is common practice to use your name, engine block. Okay. All right. What's more, there's a little bit more work to do. This time we're going to turn it around and look underneath. Okay. And then create a plane here. All right. And we need to empty inside this. All right. So to empty inside, we need a rectangle, draw a rectangle. And then offset this rectangle. Now, how much is the offset distance? I have two numbers here, 310 and 2.08. 310 minus 3.208 will give me 1 inch. okay, close to 1 inch, and if it's divided by this 0.5. Okay, let's use the offset for 0.5. Okay, that 0.5. All right, and this last rectangle is going to be extruded to empty the inside of the engine block. All right, is everybody clear on this? And finish the sketch. Select extrusion, select cut, okay, and select the area. Gonna go this way. How much is it going to be extruded? That's a question we should answer right now. I will go 1.57. So that's 1.57. Extrusion. And enter. Okay, so that didn't look right, and I want to go back and modify the extrusion. Okay, and 1.57 is actually a little bit more than that. I'm going to use a bigger number, 2.95. Okay, 2.95. Now, how do you calculate this? Again, it's all determined by the dimensions that you are given, okay, on the specifications paper, which is posted on the Schoology, okay? But now it is okay, looking more realistic. Now, there's a tradition in the mechanical engineering, okay, don't leave any corner sharp. Okay, so we need to use the fillet command to generate the round corners. Okay, just 0.1 inches is a good number. Okay, to do fillets. And the reason we have to do that is that sharp corners always are dangerous to humans and engineers. And also, mechanically speaking, this is not acceptable standard. Okay. All right. So those corners we're going to leave it around. Okay, and to avoid any kind of problem. Okay. All right, material. You're going to have to decide the material, but complete the fillet if there are incomplete or imperfections here and there. Good. This is going to be steel, but I suggest select the steel alloy. Okay, could be aluminum alloy too, or mixture of both. Okay, so let's go with the aluminum 661. Okay. All right, this is it, ladies and gentlemen. Thank you very much for your time. And then this is the engine block, and we're gonna do the engine overhead engine cover. Okay, next. But first, this is the block that pretty much we just did it today, and I expect you to do this similar. I'm going to dimension this one. Okay, and post it on the Schoology. Thank you very much.